Hello students, good day. Welcome all of you once again in this video lecture. In last few lectures we have started the chapter Adsorption and Colloids from 11th chemistry. Into those videos we studied the introductory part like definition, then some terms involved in the adsorption phenomenon, as well as we also studied the types of adsorption and the factors affecting adsorption of gas molecules on solids. Dear friends, myself is Ravindra Budwan sir from Sri Tilok Jain Higher Secondary Vidyalaya Pathradi. Now in this video we are going to study the new topic in the chapter. The topic will be adsorption isotherm and the applications of adsorption. So we shall go to the first subtopic, that is adsorption isotherm. Now what is isotherm? Iso means constant or same. Therm, this term is related to temperature. So when the temperature is kept constant and the other parameters are variable such as pressure or concentration, at these conditions the rates of some particular reactions or the phenomenon, when they are studied and the graph of, in this situation, graph of the system is plotted, then it is called as isotherm. Now here in case of adsorption we are going to plot the graph at constant temperature against pressure, and it is called as adsorption isotherm. Now what is adsorption isotherm? Here it is given the relation between amount of substance adsorbed per unit mass of the adsorbent. The relation, now this is relation, graph, that means plot. With the help of graph we are going to study the relation between what? Between the amount of the substance which is adsorbed per unit mass of the adsorbent and the equilibrium pressure or equilibrium concentration at a given constant temperature is called as adsorption isotherm. So here you can see it is important at constant temperature. So constant temperature, the plot is studied and it is called as adsorption isotherm. Particularly the isotherm which is to be studied in case of adsorption, it is Freundlich adsorption isotherm. So Freundlich adsorption isotherm, it involves the equation, or that isotherm is based upon the equation, and that is x by m is equal to k into p raised to 1 upon n. K is small, where n is greater than 1. N should be greater than 1. Now what are these terms involved in this equation? The first term x, it is mass of gas adsorbed, that is adsorbate. Here gas will be adsorbate. So mass of that particular gas adsorbed, it is taken as x. Then m, mass of adsorbent at pressure P. Mass of adsorbent at pressure P. X by m, therefore it becomes x divided by m, that is x by m. It becomes mass of the gas adsorbed per unit mass of the adsorbent. So mass of gas adsorbed per unit mass of the adsorbent, because we divide by m, that is mass of adsorbent. Therefore x upon m becomes mass of gas adsorbed per unit mass of adsorbent, and P is equilibrium pressure. So here P is taken as the equilibrium pressure. So once again look to the equation, x by m is equal to k into p raised to 1 upon n. Now we shall see actual graphs of this situation. In last video we discussed one factor, that is the pressure, effect of pressure on adsorption, and we studied that the adsorption increases with increase in pressure initially, but at very high pressures the extent of adsorption remains constant. That is, there is no effect of high pressure or increase in pressure at high value on the adsorption process. It is seen or it is studied in this graph. Now here you can see this graph is plotted of pressure against x by m, that is extent of adsorption. Here x by m will be extent of adsorption, that is mass of adsorbate or adsorbate gas per unit mass of adsorbent, so x by m. Now if you see, as the pressure increases, the mass of adsorbed gas also increases per unit mass of adsorbent, that is x by m. It also increases as the pressure go on increasing. Let's see, this is the value of pressure here, the x by m will be value here. Then again pressure is increased, the x by m value also increased, again pressure increased, again x by m value increased. But as the pressure is increased again and again, the x by m value is constant now. Now here at this pressure, this high pressure also the value is same. Here at this pressure also the value is same. That means at high pressure the adsorption extent, it remains constant, it is unaffected. This is seen by this graph. It is adsorption isotherm. Now Freundlich adsorption isotherm, this is called as Freundlich adsorption isotherm. Freundlich adsorption isotherm. Now here you can see it is plotted log of x by m versus log of p. Now here logarithm is taken, so log of the amount of gas adsorbed per unit mass of adsorbent versus or against log or logarithm of p, log to the base 10 it will be, so log of p. Now if you see this isotherm, when you take logarithms, then we get a straight line. We get a straight line, intercept on the y-axis. Now this is y-axis, so intercept on the y-axis, that is log of x by m axis, it is log of k. In the equation we see this, x by m is equal to k into p raised to 1 upon n, where k is constant. Here k is proportionality constant, so whatever that constant is there, whatever the value of that constant is there, that much value, logarithm of that value is the intercept on y-axis with this line, slope is equal to 1 upon n. So this line is with slope 1 upon n, and it is the straight line. This is known as Freundlich adsorption isotherm. Now we shall go to next topic, applications of adsorption. Now what are applications? Applications means uses. What are the uses of adsorption in our day-to-day life? That we have to study in this topic. First application is catalysis. Now we know catalysis, it is the phenomenon in which a catalyst catalyzes the reaction. Catalyst increases the rate of reaction without taking part into the reaction. The catalyst works here with the phenomenon adsorption. So for example, solid catalysts used in many industrial manufacturing processes. So in many industries, whatever in manufacturing processes are there for the different substances, the catalysts are used. Those are solid catalysts, and they show the adsorption phenomenon. They adsorb the different reactants onto them, and then the reaction takes place. So in many processes, in the industries, in the factories, this solid catalyst is used, which act as the catalyst by adsorption process. Example is given here, particular in chemistry, Fe, that is iron, used in manufacturing of ammonia. We know ammonia gas, NH3 gas. In the manufacturing process of ammonia, iron is used as the catalyst, solid catalyst. Then platinum in the manufacture of sulfuric acid, H2SO4, by contact process. Then nickel we know ranitidine or nickel, it is used in the hydrogenation process, catalytic hydrogenation we say, particularly in industry, the hydrogenation of oils to fats. This process, it involves the catalysis by metal like nickel. So these are few examples of solid catalysts which are used in the industries. Then second, gas masks. Now first application we studied the catalysis, then second is gas masks. Now we know mask which covers our mouth and nose, that is face, so mask. Now gas, what are gas masks? So it is the device which consists of activated charcoal or mixture of adsorbents. So mask, these gas masks, they are not simple or normal masks. Gas masks, they consist of activated charcoal, particles of activated charcoal or another adsorbents, different adsorbents, mixture of these adsorbents, and these are used for breathing in coal mines to avoid poisonous gases. So whatever workers are working in the coal mines means mines, khani, कोळशाच्या khani. So coal mines, for breathing, for those workers, these masks are used in the coal mines to avoid poisonous gases. So to avoid breathing of poisonous gases, to avoid the contact of poisonous gases with their noses. So if the poisonous gases enter into their breathing, then they have to suffer from hazardous effects. But here these masks, what happens? The charcoal, activated charcoal or different mixture of adsorbents, they adsorb the poisonous gases onto their surfaces, and therefore the poisonous gases do not enter into the bodies of these workers. And in short, we can say the air used for breathing is filtered for these workers. So this is the application of adsorption in the using the gas masks. Then third application is control of humidity. Humidity means moisture. So humidity means moisture. Silica and alumina gels are used to adsorb moisture. So if we don't want moisture in a particular system, then silica gel or alumina gel are kept there. They adsorb the particles of water, that is moisture, onto their surfaces by adsorption process. So it controls or reduces the humidity. Fourth is the production of high vacuum. Vacuum means no air, the space without air. So for the production of high vacuum means 0% air. So for the production of high vacuum, it can be obtained by adsorption. Adsorption of trace amount of gases remained in the vacuum, they are adsorbed on the surfaces of adsorbent. So by the way, the vacuum, high vacuum is produced here. Now how it is obtained? A vessel evacuated by vacuum pump is connected to another vessel containing coconut charcoal, which is cooled by liquid air, and therefore charcoal adsorbs the remaining traces of air from that vessel which is evacuated by vacuum pump or moisture to create a vacuum. What is done here? Here the vessel which is to be evacuated, it is evacuated by vacuum pump first, but it does not give 100% result. Some trace amount of or traces of gases remain there. So we have to remove out the traces of gases also. Then how it is done? Then it is connected to another vessel in which the activated charcoal or coconut charcoal it is kept, and this charcoal, it adsorbs the remaining trace amount of gases or molecules of gases, particles of gases on their surface by creating a high vacuum. Application number 4, adsorption indicators. Now we know indicator is used particularly in the volumetric analysis, that is titrations. Now here adsorption is used to detect the end point of precipitation titrations. So the titrations in which precipitate is obtained, and we have to see the end point here. Then in such cases the adsorption process it is applied or it is used. So how it is used? It is used to detect end point. End point means end of the titration, where we stop, end point of the precipitation, where we take the reading. Dyes such as eosine, fluorescein are used as indicators. Now in titration, which dyes are used or which colors are used? So dyes such as eosine or fluorescein are used as the indicators. Example is given here: a solution of sodium chloride containing a small amount of fluorescein. Sodium chloride NaCl solution, it is containing a small amount of fluorescein. It is titrated against silver nitrate solution, AgNO3. The reaction is given here: NaCl sodium chloride plus AgNO3. It gives the precipitate of AgCl silver chloride and side product sodium nitrate NaNO3. But here, when the chloride ions are over, when the reaction is taking place in sodium chloride and AgNO3, the reaction takes place as AgCl, it is formed, and then NaNO3, like this. When chloride ions are over, then formation of AgCl will stop. Fluorescein, it is adsorbed on the precipitate form, because when the process is going of formation of AgCl, till then no effect. But when the formation of AgCl will over, that is chloride ions are over, then the fluorescein, which is taken as an indicator here, it adsorbs on the surface of the precipitate form and it imparts its color to the precipitate. That is, that precipitate is white colored, silver chloride, white colored, but it becomes red colored afterwards, because this fluorescein is of red colored, so it becomes red colored, and end point here is the pale yellow to reddish pink. So actual perfect end point here is pale yellow to reddish pink. So this is the another application of adsorption in the field of volumetric analysis, that is titration. Then application number 6, separation of inert gases. Now we know inert gases, also known as zero group elements or also known as the noble gases: helium, neon, argon, krypton, xenon and radon. These are the inert gases. Now when we have a mixture of these inert gases or noble gases, different gases adsorb to different extent. So in the mixture of inert gases, different gases have tendency of different extent of adsorption, and therefore we use this adsorption phenomenon for the separation of these gases. So due to selective adsorption principle, these gases are separated on coconut charcoal. So whichever gas it is adsorbed in more extent, it remains with that coconut charcoal for more time, but remaining gases, those we have less extent of adsorption, they are obtained first. In this way we separate these gases on coconut charcoal. Seventh application is froth flotation process. Froth flotation process, this is used in the separation and purification of crude materials, crude ores into the pure substances. So here low grade sulfide ore, low grade means impure, not pure. So sulfide ore, it is the impure mixture in which sulfide is present. So sulfide ore is concentrated, that is separated from silica and other earthy matter. Earthy matter, matter of soil or earth, matter containing soil or earth. So this sulfide ore, it is concentrated. Concentrated means its concentration is increased. That means impurities are removed. So how impurities are removed? By separating from silica or other earthy matter. Silica means SiO2. silicon dioxide. So by using, now what is used here? By using pine oil as frothing agent. Here frothing agent, because we have to get this sulfide ore in froth. So for this frothing agent is used, and that is pine oil. Hydrophobic pine oil, hydrophobic means which is heating the water, that is which does not dissolve into water. So hydrophobic oil, pine oil, it adsorbs on sulfide ore. It adsorbs on the sulfide ore and takes it up in the froth. So it takes this sulfide ore into froth, and hence it is separated from the silica or other earthy matter, that is impurities. Last application of adsorption, dear friends, it is chromatographic analysis. So we know chromatography is also the technique for separation of the mixture of two or more components. Here this chromatographic analysis, it is based on the selective adsorption of ions from solution using powdered adsorbents like silica or alumina gel. Now here we use this adsorbent, that is silica gel or alumina gel, and the mixture of different components in the form of solution, it is poured on it. So the component which has more tendency of adsorption, it is obtained afterwards, but which has less tendency of adsorption, less capacity of adsorption, it is obtained first in the eluate to us. So it has several industrial and analytical applications. Now this technique, chromatographic analysis, by using this technique, that is adsorption, it has very large industrial and analytical applications. There are many more applications in the industries in the field of analytical chemistry or analytical techniques. So these are some applications of adsorption. In the next video we are going to study the another topics, that is second concept of this chapter, that will be catalysis. So don't forget to see my next video. Thank you very much.